Hello, everyone. My name is Nancy Duong. I'm the administrator here at Solomon Park Research Labs. Today, we have a very special guest. We have the founder of Solomon Park Research Labs, Patric Clapshaw, joining us. Thank you, Patrick, for joining us and being here on the podcast today.
You're quite welcome.
So, we'll get right into it. I wanted to ask, how did you find Solomon Park? What got you started? Was there like a specific problem that you needed to solve to get the lab started?
Actually, no, I was a research scientist and I was working at another institute. I wasn't very happy, but quite honestly, I had wanted to have a laboratory of my own as long as I could remember. I even one time converted my garage from a double door to a single door just so I could have my laboratory and half of the garage. Turns out I didn't
Uh,
have to do that. I didn't have to do that because I had, by that time, I was doing ALS research, and one of the groups in Seattle invited me to give a talk to their group, and I mentioned the fact that I didn't have a lab, and I was converting my garage to a lab. And one of the owners of a complex of apartments, not apartments, yeah, just apartments. No, it was office space, I guess. Said that he would give me 2 years free if I would continue to work on ALS. So that was like my first grant. So that was worth quite a bit of money.
um,
So I converted an office space into a lab. At that time, Sean's mother was alive, and she was a medical technician, and she came from a family that had done a hotel, sort of small business all her life. So she was quite good at business. I was quite honestly terrible at it. I didn't even know how to begin at all.
you're the
And
brains.
so, all right, well, I was just a scientist who wanted to have his own lab, but had no knowledge of how to do it. Anyway,
Mhm.
so we got this free space and we started working on it. And as she told me, you don't have to worry about forms because the state will find out you're there and they'll start sending you money. So you fill out the forms that way. And what else can I tell you? Um, well, and also there was a small nursing group associated with this ALS society, and they wanted to share part of that space with us. So we had kind of a good setup because we had a nursing group working with people who had ALS, Lou Gehrig's disease, and our laboratory doing research on it. And Sean's mother was an incredible asset because she knew how to start and run a business, and B was a medical technologist. So we started right away with good a good surround. So I came to it with the idea that I wanted to have again my own lab, but also we did have a project we were working on ALS. And then the next turning point, an incredible one, was I would always go around and give talks to these ALS Society groups. There were several of them all over the Puget Sound area. And I just felt these people were in such desperate straits that I would always go. I never asked for even gas money to go there and talk to them about what the most recent research in ALS was. And my board, a couple of my board members said, you should charge at least a fee. And I said, no, I just can't bring myself to do that. But anyway, one of the ladies who had come to my meetings died of the ALS. All of them were, pretty ill. And
Mhm.
she left me a large, about a $2 million, um, what would you call it, in her will. She offered,
Inheritance.
left our laboratory at least a good $2 million to do research.
Wow.
So at that time, we had two institutions. And I got this idea from a place called Roche. They made Valium at that time. They made a lot of money off that. But what they did, I went to a talk there. A friend of mine I'd worked in Germany with was giving a talk there. And they took me on a tour of the Roche Institute. And it turned out that Roche had an institute and they had labs. And one was a for-profit business, just like any business. And the other was a nonprofit institute that just did research on something to take the place of, I'm pretty sure it was Valium. It was one of the original medications that a lot of people took to calm down. Anyway, I said, yeah, that's a good idea. Because I had already a grant in ALS, and I'd bought quite a bit of equipment on that grant, and I talked this guy into letting me come to his laboratory and work there. And his lab was a nonprofit, but to keep money and to keep equipment, you had to have a nonprofit. You couldn't go to a business. You just have to leave all your equipment behind. And so I started both the institute and a laboratory. The institute was not for profit, and the laboratory was for profit. Took me a while. I remember going to work every day on the bus going down to Seattle, reading a book on how to start a nonprofit institute. It took me about 2 years to figure out what we had to do. It's actually quite surprising. You really don't have to have a business with a nonprofit because, well, first off, let's back up a second. The word nonprofit is kind of misleading. I don't know why they call it that. All it really means is that you don't have investors, people who, invest money in your laboratory or whatever you have, and they want dividends, or they want, from your profit, you give them a certain percentage of your profit every quarter. And the problem with that is they put enormous pressure on the scientists to produce something every quarter so that they get some money out of their initial investment. And a nonprofit has a board, all right, but it's just the opposite. They do not want you to be pressured into just making money. They want you to do the science properly. So that's why I kept the nonprofit. So anyway, we started out with, in fact, our email and everything that you see is at the end, it's .org instead of .com. And the reason for that was when I first started the laboratory, I wanted, things were quite rather primitive at that point with the internet and everything. And so we had to decide how to make our internet connections and everything. And the laboratory was just beginning, and the institute already had quite a bit of work ahead of it. So we chose .org at the end to, give us email for everyone. So the reason you're not a .com, if you notice in your email, is because we had to choose one or the other, and we chose the .org. So that's
I think you made a good choice.
Yeah, well, a lot of people wonder why we have .org instead of .com. It's nothing altruistic. It's just we had to choose one or the other.
So at this point, did you have Solomon Park Research Labs yet, or are you still doing research for the ALS?
Well, actually, I started out the laboratory by doing research for ALS because I had a grant already. So I requested the people who had given me the grant money to allow me to transfer my grant from where I was. It's a place called the Issaquah Health Research Institute. You can kind of understand how our laboratory got its name because we're Solomon Park Research Institute. So I made the I named. I thought that was a good name. And Solomon Park. I'll tell you a minute where that came from. But anyway, the Solomon Park Research Institute just started doing research in ALS. That's what we did very first. And that, again, as I said, turned out to be a lucky thing for us because I would go to these little meetings all over the area and give a talk, bring people up to date. These were people that had ALS, and they would
Hmm.
come to these things, and I would just bring them up to date on what research was going on. And sometimes I would bring someone that was in another lab working on some part of it, and so it was a nice what you call it something to do for the community. I
Hmm.
never had to ask for any money, and it was quite unexpected that I called one day from this lawyer telling me this lady had left us around $2 million, and
Yeah.
she. So anyway, that jumped the institute into being much more prominent than the lab. I remember I decided that I would just split my income from between the lab and the institute because I already had some people I'd hired in the laboratory to mainly do what they would work on would be to do what we're still doing, and that was to do analysis of different things in the blood of people that had ALS. Like we weren't quite ready to do DNA research, but after we got the money from this lady, we went into doing DNA research, looking for genes that may be different in these people. Turns out to be really difficult to find, but we wrote a couple of papers on that. I hired a young woman from India and another young woman from China. The young woman from China had a MD, and the young woman from India had a master's degree in molecular biology. And she had that from a rather well-known laboratory down here in the Portland area. So anyway, that's how it all began, and that's the bolts of it. Quite a bit of things coming together. Let me think, what else can I tell you? Well, and the laboratory ran on that $2 million. Nowadays, it would be gone in like 2 weeks, I imagine.
Yeah.
But in those days, I got that in 2000, and we didn't run out of money on that until 2011. So we
Hmm.
managed to run the institute for 11 years and $2 million. And in that time, of course, my laboratory was still working. And that has its own interesting story. Before I'm giving you a lot of information here on grants and things. The grant that I had from this place for doing ALS research would not pay any overhead. You may have heard recently that the Congress has begun complaining about what they call indirect costs. And what happens is, say an institute or a university gets someone with a grant, say it's $1 million grant. And when they accept that, they also demand an additional two or three. Oh, hang on a minute. That's a pause this thing. Something I'm going to have this dog here. Yeah.
I was gonna ask you, you wanted to talk about where you found the name behind Solomon Park Research Labs.
Yes, let's do that. Yeah, many people want to know, besides the .org that we have at the end of our email instead of .com, like most businesses do, many people ask me where Solomon Park came from, and why Park and what's Solomon all about and everything. So at any rate, when we first decided we were going to start our own laboratory, um, Joan, that's Sean's mother's name, and I thought, went through all this thing trying to name a place. Turns out to be a very difficult thing because, to name an establishment is not simple. You don't want to pick out something silly because you'll
Mm-hmm.
sound silly. You don't want to get something too, uh, prominent or too stiff because you'll always sound prominent and stiff. So anyway, we spent at least 3 months arguing about what to name this place. And
Wow.
a lot of people name things after their family members. We tried my
Mm-hmm.
father's name, my mother's name, that sort of thing. But neither of them ever had any problems with ALS or even heart disease. We had already started after we got started a laboratory, and we were working with the Centers for Disease Control to isolate apolipoproteins, the protein moiety, they call it, protein strand that carries cholesterol from our livers to our cells all over our body. A very important molecule. But anyway, so we had that going, and one day I asked Sean's mother, well, what was your father's name? I'd never met him because he died many years before I met Sean's mother of a heart attack. And I said, your dad died of a heart attack, and we're working on cholesterol, which a lot of people know now is causative, gives you some other reason to get a heart attack. Well, I don't know his name. I never did know his name. Well, his name is Solomon. I said, Solomon, that's a great name for a laboratory, Solomon Labs. It just seemed a little short. What's his middle name? Park. Well, that was the end of it because
Oh,
there
wow.
was a very famous laboratory that made media. Media is just the salt solution you pour on cells when you want to grow them, called Roswell Park Memorial Institute. And Roswell Park was the name of this woman who died of cancer back probably in the 1950s, maybe even
Mm-hmm.
before. So that was a well-known laboratory system, Roswell Park Memorial Institute. So we should name it Solomon Park. And then I had been at this place called Issaquah Health Research Institute. We don't want to do memorial, but how about Solomon Park Research Institute? And everybody thought that was wonderful. So that's where that name comes from her father.
Wow,
So,
that's amazing.
and he did die of a heart disease at a fairly early age, so it was quite appropriate. The laboratory,
Hmm.
anyway, wasn't
Yeah,
entirely
you have
appropriate
a
for
personal
this.
connection to the name, and it's kind of
Yeah,
it's
in
like
fact,
a remembrance in your late wife's father.
yeah, and you see it especially the lab. And I'll tell you another thing about that name, and that is almost every new laboratory system is cell systems or tissue systems, or all these rather bland, very confusable names between one cell system and another. I mean, I can't keep them straight. I couldn't even
Uh-huh.
keep them straight then when there weren't that many of them, and nowadays it's impossible.
Hmm.
Solomon Park stands out. You go to a meeting and everybody's, I'm from Cell Systems, I'm from Cells and us, or whatever. And then they
Hmm.
get to me, I'm from Solomon Park Research Institute. Immediately people think, well, what's that? Where's that from? Where'd you get that name? So people remember our name quite well because of that.
Hmm.
We named it after Joan. Joan, that's Sean's mother's name, her father, who died of heart disease. And most of the meetings we went to early on were through the business because that we made our own money, so we could decide to spend it traveling to meetings and such. Whereas the institute's money, we had to be careful what we used it for because we had a board of directors that didn't want me traveling all over the place just having fun instead of staying home and doing research. So, or at least not paying for it. So anyway, we had that. I had a small group in the institute. I had the two researchers I mentioned earlier, and we had a woman who worked half time up in our front office, and I had a half salary. So that's how we did it for the first, 11 years, I think. Well, actually, we started the laboratory quite a few years before that. I'm trying to think. Oh, I remember now. We started the laboratory in 1984, February 1984. Oh, it seems so long ago, Nancy, I swear. I've forgotten some of the details. That's how long ago. When we started it, we're 41 years old this year. So, and I've read before that 85% of all small business startups go broke within the first 3 years. So we got
Yep.
past that.
Mm-hmm.
And then of those 15% that weathered the first 3 years, 85% of those were gone by 5 years. And we
Mm-hmm.
got through 5 years. So we were down in a fairly rarefied group of people by that time. And I think 84, 85, 90, we're still only in the 90s. And I still had to get a lot of my income by working at the University of Washington.
Mm-hmm.
And I was working in, we were a cardiology laboratory working on what caused heart disease and that sort of thing. So I was quite adept at that also, besides ALS research. And we didn't have any money really to speak of in the institute because we had a grant that lasted a couple of years, and I had all my equipment, and we did do some research, but by the time we got anything going, we had run out of money, and so we depended more on our institute. I mean, our laboratory for money. We were starting to get more and more products and things we could sell, just like now, just exactly like we have now.
Yeah. So
So,
can you go into talking about your first product?
yeah. Well, the first products we made is that people at that time were isolating HDL, LDL, not triglycerides. And just so you remember, I know I explained this to the lab before, but let's just take LDL. LDL is basically a big protein, and then hooked to that are cholesterol atoms. And that protein, it makes it soluble in blood. Otherwise, it would just clump up and be stuck somewhere in the side of one of your arteries for a future heart attack. But cholesterol itself, it's like pouring oil into water. It just bubbles up and sits on the top and can't go into solution. So what the body has done many, many eons ago for us and every other animal is they make this protein, either LDL or HDL, these two proteins, and those will allow you to attach cholesterol to them in such a way that the protein now is soluble in water or in blood. So it can float around to these cells, and it also has things called receptors on the. So the cells have receptors for something on the LDL or the HDL. And so it floats around and it bumps into a cell with the right receptor oriented toward it. And that will allow the cell to engulf the LDL particle with the cholesterol. And what the cell does inside is it tears it all apart and puts the cholesterol, which is very important, in our membranes around our cells. So people were naturally very interested in the LDL and HDL particles and how they worked. And I went down to the University of Washington and bought an ultracentrifuge for like $51, an old one, a good one. And I remember when I bid on that, I figured somebody's probably going to bid at least $50 on this, and nobody wanted it. It was an old one, you know.
Mm-hmm.
So I thought, well, I better do 51. I thought of 51 or $53. And I finally decided to do $51. And sure enough, some guy had bid with me, but he had bid $50 and I won it by $51.
Woohoo!
So we got that to lab, and I trained Sean, who at that time was still in high school, and I think she was still alive. Yeah, we were doing ultracentrifugation of blood and isolating the LDL and the HDL. And a lot of people were buying it from us. Well, that phase of cardiac um, research is pretty much over now. They don't really need very much of that. We were producing upward toward a gram of LDL every month. So we had that centrifuge running all the time. In fact, I bought a second one ultimately. So that was the stuff we started on. So we were doing ALS research on our own, if we could find anything inexpensive to do. And then we were starting to make more and more income through the lab.
Mhm.
And our big break came was while I was still working at the University of Washington. A woman there that I had become friendly with from Vietnam, a place you know, right? Her
Yes.
name was Thuy Nguyen. Anyway, uh, she liked me a lot because the guy running the place was not very friendly. He was not very nice toward her. I mean, I think he was a bit of a chauvinist myself. Anyway, I'd find her in the break room every once in a while crying, and I
Oh.
would, yeah, I know, it was terrible. You don't have to put all this in the studio, but anyway, Twee would be unhappy with her situation there, and she was a very important one. She did what was called the reference procedure to measure LDL and HDL and cholesterol in general, called the Abel Kendall. Anyway, I knew that, and I would talk to her, and I would commiserate with her woes and that sort of thing. And anyway, of the Centers for Disease Control called the University of Washington, wanted to know if they would be able to take over making the calibrators and controls for this big program they had that goes all over the world called the LSP program. And you know that we still have it, lipid
Lipid
standardization.
standardization program. Mhm.
And I just jumped at that because this is a very famous laboratory, the Centers for Disease Control. And it also had this big project all over the world. And so we said, yes, we can do that. And I think they were a little bit leery because we were kind of a small lab. And they sent someone out to check us out, and we had ultracentrifuges by that time thing. So they hired us, I think in 1998. They hired us, and they wanted to start this new way of making the pools for um, calibrators and controls. And that got actually published in at that time it was the NCCLS. It's a nonprofit institute that publishes papers from both industry and institutes. And they wanted this new procedure that would, it's rather hard. If you take blood and you freeze dry it, which is what most people want to do, because you can send that much more cheaply. But when you try to reconstitute, especially for cholesterol, when you try to reconstitute that with water and measure that in a machine, it would never work right. I mean, there are many, many problems. One is people would not add the right amount of water, or too much or too little, or it wouldn't go into solution correctly. Every machine read a little bit differently. Some machines would read it closer to the true value, other machines would be way off. So they wanted a commutable serum product that would give the same answer on every machine. And they gave us a procedure, and we worked on that, and we also made our suggestions. And that's the C37A procedure. C37A is just the name given to the NCCLS for the write-up they did on it. So if you go to the NCCLS and ask them for a C37A procedure, which you probably have to pay a couple of $100 for, that would be the write-up that we made for that product. And that
Amazing.
product it's turned out to be absolutely amazing. I mean, it's still heavily used by the entire industry
Yeah, I mean, we're
because
still using it at the lab too.
we
We're still
do,
making
because
those products.
it's better than anything else. If you buy cholesterol reagent from Roche or some other company, or Smith Klein, which is now gone, sold out to I think who they sold out to. But anyway, these labs buy and sell each other quite frequently. But if you buy the reagent, they will send you controls and calibrators. And they make one set of controls and calibrators for everybody. And again, if you use that in different machines, you get different answers. And they weren't just trivial. I mean, I read somewhere that a 200 cholesterol that they established with 200 would read industry-wide anywhere from 160 to 240. So 160 gives you a nice cholesterol, and you can eat all the cupcakes you want. And the 260, you better just eat dirt and drink pure water, otherwise you may die next week. So anyway, it was terrible. It was really quite terrible. They could not get a product that would read the same in everybody's in every laboratory. Mainly it was equipment. Like, we have the AR 400 now in our laboratory from Beckman. But before that, we had a Hitachi, which was quite good. But this product we've made all these years will go to any machine anywhere and give you the right answer. It's kind of amazing. And so the CDC used that for this LSP program they had going worldwide. And we still have most of those people as customers for that program. That's another story, how we
We
have
do.
them as customers.
Yep, it's
Mhm.
still an active program that we have today.
Well, see, it was when we first got it, when we first started it, we just made the calibrators controls, and the Centers for Disease Control then bought those from us. And they would send them to these different laboratories to measure it. And the idea was that they would measure these, and then that would give them a control value that would be close to the Abel Kendall that my friend Twee did. So, it was immediately famous. I mean, I one time counted up 30 or 40 important research papers, and every one of them used our materials to do research in low LDL and HDL. I remember
And
reading, yeah,
you remember reading what?
I remember reading at the time how much money was saved nationwide, not worldwide, but just in the United States. How much money was saved by people being able to identify people with high cholesterol and keep them from getting, heart diseases and stuff. And like something like 10 trillion and $5 trillion or something was saved over 10 years or something. And I remember talking to this guy and said, can't we just have like 1%? We'd still be trying to spend all that money. But anyway, he said, no, it doesn't quite work that way. I did it as a joke, of course, but it saved a lot of money in that field, and it brought a lot of people results to be compared. I mean, the problem was, of course, if people would have these different machines in their laboratories, And so they would try to measure cholesterol on somebody. And that person would go to maybe 5 laboratories, and they would all get different results. And they were too
Mm-hmm.
far apart to really make a very good comparison.
Right.
And that was the whole reason for our product, or the
Mm-hmm.
product of the CDC. So when we were able to develop, and the CDC sent people out to help us, but we mainly did most of the grunt work on that. When we were able to send that out, they were suddenly able to compare all these different laboratories. So they could look at results that they'd gotten and compare them to other labs. And it was, it was a breakthrough. It was a very important breakthrough. So if we'd had at that time, what is it?
Cold solutions.
Pulse, yeah. Anyway, we didn't have any of that in those days. We just were well known because the CDC would mention this to people whenever they had conversations with other groups. And also every year at the AACC meeting, they would have a roundtable and describe our product. It was, their LSP program, but they also described that Solomon Park Research Laboratories made this stuff. So a lot of people would order from us their own in-house calibrators and
Mm-hmm.
controls, so we could sell those separately. So anyway, that's about our product, which is still in high demand. I mean, I don't quite know how to describe that to you. Most machines companies actually would begin to gear their machines toward getting the right answer.
Mm-hmm.
If they were off by any great amount, they would work on their reagents or their machines to get their values to come close to what
Well,
they
I
could
think
get.
I think
Yeah,
why our product is so has such quality is because we're making it straight from the source of only serum of from humans. We don't have any additives or anything in it. It's just pure, right?
that's exactly right. There's two more things to add to that. One is that we don't freeze dry it or anything like that. We don't add anything to it. You can't add cholesterol to it. It just goes to the surface like oil. I mean, it's very difficult to get into solution, cholesterol. I mean, you couldn't just pour like we do for, what is it? We can put creatinine into our blood and change the value, increase it,
Mm-hmm. Mm-hmm.
because that goes into solution. It's soluble, like salt, anything like that. But cholesterol, they have pure cholesterol you can buy from the NIST, National Institute of Standards and Technology. They have pure cholesterol, but if you pour it in the blood, it just sits on top of the blood. It doesn't go into solution.
Yeah.
So you
Got the
can't,
mix.
you can't do it that way. You have to find people who have high cholesterol or low cholesterol. And then the second big factor is speed. We draw it in the morning. By that afternoon, literally, we can freeze it down on our -70 freezers and keep it, from degrading. So, we were very careful. We become a little less careful with, sometimes it goes 2 or 3 days before we freeze it down because we're using it for other things, but it doesn't seem to influence it much, just as long as it's within 48 hours or so that we get it frozen. I know that I come into the lab whenever I go up there, and if there's anything in our refrigerator, I always complain because it's just sitting there, and I want it frozen down in the freezer as soon as possible.
Mm-hmm.
But anyway, speed and the natural occurrence in the human population. I mean, we've had people all the way from 100 cholesterol to 400 cholesterol. The 400 cholesterol, I might add, have all died. They died within 5 or 6 years. But That's just way too high.
Mm-hmm.
Anyway, that's the history of our main product. We've added since then, as you know, we've got quite a few um, different analytes that we make controls on, calibrators for people to use.
Right.
And we try,
This kind of set the foundation of being able to create all the other great products that we had too. So you had these cholesterol, calibrate controls, and now we were able to have things for like, testosterone and like thyroid and whatnot. It really
yeah,
set it in place to be able to make these other controls.
yeah, that's right. We just extended that procedure that we got from the CDC from
Mhm.
cholesterol to all the other analytes we do. We try very hard to find naturally occurring levels in people. I'm sorry, my phone's beeping. We try very hard to find people who naturally have high creatinine, say, or low creatinine, or
Mhm.
and in the case of creatinine, as I said, we can add a little of that, but we try not to add more than values of 25% up or down. So
Mhm.
that's one thing we try not to get carried away of how much we add. We find people, say, with high creatinine, and then we will add 25% of that to get the highest value we can. We could dump in huge amounts, and that would probably work, but we don't like to push the fates, as it were. So, and we just extended that procedure out to making other things that are measured in the laboratory, and they tend to work very well. We've never had a single product that we made that did not give these really good results, and mainly because it pretty much mimics the blood right out of the person.
Mhm.
So it's just it becomes a natural product. A lot of our stuff
Right.
is just right from people.
Yep, right from the source.
Yeah,
All right.
yeah,
Well, thank you so much, Patrick, for taking the time to share your journey and insights with us today. It's been incredibly insightful um, about learning about how Solomon Parks and your breakthrough research to get how it is today. For our listeners interested in learning more about Solomon Park Research Labs and the service and products we provide, you can also visit our website at www.solomon.org. Again, thank
yeah.
you,
Well,
Patrick.